Greetings. Today we are going to solve one network problem using superposition theorem and nodal analysis method, also mesh analysis method. So using these three methods, we are going to solve a single network problem. It may take some time, but be with me, learn. Okay, so let's do it. So this is the given problem. This is a given problem. We have to find the current what that is flowing through this 30 ohm resistor. That is what the question. First we will use superposition theorem, then we will use the mesh analysis and nodal analysis. So let's start. So in superposition theorem what we do, okay, in three steps we will solve this problem using superposition theorem. Step 1, we will consider only one voltage source at a time, only one source at a time, and in the other source we will deactivate. So now first I will consider only the 50 ohm 50 volt 50 volt voltage source, that is 50 volt voltage source. We have three resistors like this network. What are their values? This is 50 volt voltage source, 10 ohm, 10, 20, 30, and we are going to deactivate the second source. How do you deactivate a voltage source? We have to use a short circuit. It will be, this voltage source is replaced by a short circuit. Now what is there? We have to find the total current, the current I. Let us take it as I, the total current I flowing through this circuit. How do you find total I? We have to find the equivalent resistance. Now here, equivalent resistance, what is the equivalent resistance? See, this entire circuit can be replaced by a voltage source, that is our 50 volt voltage source, with a equivalent resistor. This is the R total resistance of this network, that is RT. This is RT. Now RT we have to find. If we see here, this 20 ohm and 30 ohm are in parallel. So 20 ohm 20 ohm parallel with 30 ohm. What we get? So R equivalent, what we will get when these two resistors are in parallel? We will get 20 multiplied by 30. I hope all of you know this. 20 plus 30, that is 50. What we get? We get 20 multiplied by 30, that is 600 upon 50. So it comes to 12 ohm. 12 ohm. This 12 ohm is in series with what? This 10 ohm resistor. So RT, what will be RT? That is 12 plus 10. We'll get 22 ohms. So now this RT equal to 22 ohms. We got. Now what is the current flowing through this circuit? I. What is the current flowing through this circuit? That is I equals, we'll apply the Ohm's law. 50 upon 22. What we get? 50 upon 22. 50 upon 22. 2.272. 2.272 amps we'll get. 2.272 amps. Now we got the current. Now what we have to do? We have to find what is the current flowing through this 30 ohm resistor. Correct. Then what is the current here? This is I, that is 2.272 amps. Amps of current is flowing. Now here we'll apply the current divider rule. Using the current divider rule, let us take it as this as I1 and I2. This as I2. What is the current entering here? That is I equal to 2.272. Now what is we want? I1 we need. I1 means opposite branch resistance, we are applying the current division rule. That is opposite branch resistance. What is the opposite branch resistance? 20. Sum of two resistors, these two. When the current dividing those two resistors, you have to add it up. That is 50 multiplied by the incoming current I. What is the incoming current I? 2.272. So what is the current flowing through this 30 ohm resistor due to voltage source 50 volt? If we simplify this, what we will get? 2 upon 5 multiplied by 2.272. It comes to 0.908. It comes to 0.908 amps. So now we got the current due to 50 volt source, 50 volt voltage source. Now we will see with the, okay, now we'll go to the next page and we'll see that. So I1 we got. What I1 I will write it here. What is the I1 value we got due to 50 volt source? That is 0.908 amps we got. Now I will deactivate the 50 voltage source and then I will calculate the current through 30 ohm resistor. Now I'll draw the circuit. So this is 10 ohm, 20 ohm, 30 ohms. Now what I do, I am going to deactivate the 50 volt source. So we will replace with a short circuit. So this will be 20 volt. Now we have to find, due to this 20 volt, what is the current flowing through this 30 ohm resistor. So I will mark it as I1 dash, I2 dash, I2 dash. Now we will simplify. Now what happens? Now if we see here, the like previous, this is a step 2, okay? This is a step 2, what we are going to do. Step 2. First, using the step 1, we have found the I1, whatever the current flowing through 30 ohm resistor. Now next, we are deactivated the 50 volt source, and now we are only connecting 20 volt voltage source. Now these two, now RT, similarly, similar to the previous step, here also we can replace this circuit with this 20 volt voltage source with the equivalent resistance. That is, I will take it as RT. We can replace that RT. Then we can find the current through it, I. Now we will find the equivalent resistance. What is the equivalent resistance? So 10 ohm in parallel with 30 ohm. What is the value we get? 10 ohm parallel with 30 ohm. So R equivalent to 10 multiplied by 30 upon 10 plus 30, that is 40. It will be, what will come? 300 upon 40. What is 300 upon 40? 300 upon 40. It comes to 7.5 ohms. 7.5 ohms. So it is coming to 7.5 ohms. This 7.5 ohm is in series with what? 20 ohm resistor. 7.5. So RT, what is the total resistance? The 7.5 ohm is in series with the 20 ohm resistor. So 7.5 plus 20, we will get 27.5 ohm. Okay, now what is the current flowing here? That is I equals 20 upon RT. RT we got, that is 27.5, which equal to what? 20 upon 27.5. It comes to, what is the value it comes? 20 upon 27.5. Is it correct? Yes. 27.5 we got. 27.5 we got. Now if you divide 20 upon I, correct, 20 upon 20, what we are getting? Let me calculate once more, some little doubt. 20 upon 27.5, 0.727 I'm getting. Let me check once. Yes, I got 0.727. 727 amps I got. Correct. We got 0.727 amps. Now we have to use the current division rule and find what is the now we are applying here. So here I is flowing. I equal to what? I is flowing. That is the I equal to 0.727. Now we are going to apply the current division rule here. I want the current I1 dash. I1 dash equal to what? I1 dash equal to opposite branch resistance, that is 10, sum of the two resistors, that is 40, multiplied by the total current 0.727. So it comes to what? 1 by 4. 0.25 multiplied by 0.727. It comes to 0.181. 0.181 amps we got. Now if you see, so I1 dash also we got. In the both, when we consider when both voltage sources are connected, current direction is in the same direction only. Why? Because current will flow from higher potential to lower potential. So what is the effective current which flows through uh, current which flows through? So we can write it as current which flows through 30 ohm resistor equals to what? I1 plus I1 dash. You have to take the algebraic sum, but current direction is same, so it will be 0.908 amps plus 0.181 amps. So what will be the value total? Total comes to what? Which equals, let me check what is the thing. 0.908 plus 0.181, which equals 1.089. 1.089 amps we are getting. 1.089 amps. So this is the answer by using superposition theorem. Now the same problem we will solve with mesh analysis. We'll go with the mesh analysis. So we'll start the mesh analysis. Now same problem I'll write once more, then we'll start the mesh analysis. So now we are going to apply mesh analysis. How to? Using mesh analysis, how to calculate this? Calculate the current through 30 ohm resistor. So this is 50 volt, this is 10 ohm, 20 ohm, 30 ohm, 20 volt source. The mesh analysis, first I will assume take the current direction. I will take the current I1 is in the clockwise, flowing in the loop 1 in the clockwise direction. Second loop also I assume current I2 is flowing in the clockwise direction. Clockwise direction. Now okay, we have to apply the KVL. The mesh analysis, what we do? We will use the KVL. This is mesh analysis. Let me write it. Mesh analysis. Using the mesh analysis, LL. Mesh analysis. Now, okay. Now I'll write the loop equation for the first loop. This is the first loop. Then this is the second loop. First loop. I'll start from here. Rise in potential. So I'll write it as 50. Again, it's a fall in potential because current direction. This I have explained you before. previous questions. See, some examples already I gave you. So if you are not, if you feel difficulty, please go through those example problems. So here also, when current flows in the clockwise direction, this end of the resistor is supposed to be positive, this has to be negative. So it's a potential drop. So minus 10 I1. When one resistor is belong to both the meshes, what do you do? First you write the plus, you'll put a plus sign and write the resistor value. Then see in the loop 1, if you see I1 is creating a potential drop across 30 ohm resistor, but I2 is creating a potential rise compared to I1. So we will write it as I2 minus I1 equals 0. Now we'll open the bracket. 50 minus 10 I1 plus 30 I2 minus 30 I1 equals 0. Now 10 minus 10 I1 plus if you add these two, we'll get it as minus 40 I1, then plus 30 I2 equals minus 50. We'll divide entire equation by 10. So we should get minus 4 I1 plus 3 I2 equals minus 5. So this is our first loop equation. This is our first loop equation. Now I'll write the second loop equation. Second loop we will write it as loop 2. Loop 2. I will start from here. The loop 2 I am starting from here along the current direction. So this resistor belongs to both the meshes. So I'll write plus 30. 30 plus 30 means because it's first term, no need to write plus 30. So what's happening? Current is flowing like this. That means this I2 is creating a potential drop here, but I1 is creating a potential rise. So we'll write it as I1 minus I2, close the bracket. Then here we are going through. Here if you see, current is flowing in the clockwise direction. So this will be plus, this will be minus. So it is a potential drop. 20 I2. Again it is a potential drop. From positive terminal of the battery we are going to the negative terminal. So minus 20 equals 0. Now we'll open the bracket. That is 30 I1 minus 30 I2 minus 20 I2 minus 20 equals 0. Minus 20 equals 0. Now if we simplify, this is 30 I1 minus 50 I2 equals 20. So what we do? We'll divide by 10. So 3I1 minus 5I2 equals 2 we'll get. So this is our second equation. Now we'll simplify these two equations and we'll get the current through 30 ohm resistor. Let's see what, okay, we'll write the equations. That is minus 4I1 what is there? Minus 4I1 plus 3I2 equals minus 5. What is the next equation? Second equation, second loop equation, 3I1 minus 5I2 equals 2. Now I will cancel these equations. I will simplify. So I am going to simplify. Minus 4. With these 3 I will multiply the first equation. That is minus 12I1 plus 9I2 equals minus 15. Minus 12I1 plus 20I2 equals minus 8. Now if I subtract, this will cancel. 9 minus 20 minus 11 I2 equals minus 15 minus of 8. So it will be minus 7. So what is I2? I2 equals 11 by 7. What is 11 by 7? 11 upon 7. 11 upon 7. What do we get? We get, let me check once, any mistakes. 1 point. Is it correct? When we simplify this, we'll get, okay, 11 upon 11 I2. Oh, sorry, 7 upon 11. Correct. Yeah, 7 upon 11. Sorry. This is 7 upon 11. 7 upon 11. So which comes to, let me check, 7 upon 11. It comes to 0.636. 0.636 amps we got. Now, we have to find I1. So I'll put here this second equation. I will take it. That is 3I1 minus 5I2 equals 2. So okay, I'll put it 3I1 equal to what? 3I1 equals 2 plus minus 5I2 will come other side. 5 multiplied by 0.636. What is it? So 3I1 equals, what is the value of 5 multiplied by 0.636? It comes to 3.18 plus 2. So 5.18. 5.18. 5.18 we got. Now I1 equal to 5.18 upon 3. 5.18 upon 3. So 5.18 upon 3. It comes to 1.726. 1.726. 1.726. We got both the currents we got. 1.726 and 0. Both are positive currents. Now we'll see here. Now if we see here, I2 and I1 are in opposite direction. So we will take I2. We'll take I2 minus, what is the I1? We will take I1 because I1 we got higher value. I1, effective current I equal to I1 minus I2 we will take. So what is I1? I1 equal to 1.726 minus 0.636. It comes to 1.090 amps. So exactly same answer we got. So the 30 ohm current is flowing from where? Through the 30 ohm resistor. Current is flowing like this. So exactly same answer we got. So we have done with mesh analysis and the superposition theorem. Now we will try to find using what? Nodal analysis. Now I'll apply nodal analysis to this problem. So now we are going to do with nodal analysis. So I will draw the circuit once more. So nodal analysis also will verify whether we will get the same answer. So it's 50 volt. This is 20 volt. This is 10 ohm, 20 ohm, 30 ohm. So we will consider the this node. This will be the reference node. And this is this voltage at this node. We will take the voltage as V. Now I am going to apply the nodal analysis. So I will assume that all currents are going away from the node. Now I'll write it. V minus, I'll write with green pen. V minus 50. No, before that let me write the currents. Let me mark the currents. So this is, I will take it as I1, this is I2, and this I3 current, I3. So I1, all are outgoing current. So I1 plus I2 plus I3. Outgoing current equals to incoming current. Incoming current equal to 0. Now I will apply the we'll try to find what is I1. I1 equal to what? V minus 50 upon 10 plus I2 is the I2. Here it is 0. So V minus 0 upon 30 plus I3. V minus 20 upon V minus not 20. V minus 20 upon 20. Voltage also 20, resistor also 20 equals 0. Now we'll simplify. For what I will do, I will multiply the whole equation by 30 because my LCM is weak. So I will multiply the whole equation by 30. So it will be V minus 50 into 3 plus 30 cancel. So it will be V plus here we will get 30 divided by 20. So 3 by 2. So 1.5. 1.5 multiplied by V minus 20. V minus 20 equal to 0. Once we get to the value V, we'll apply Ohm's law and find the current through 30 ohm resistor. So now we'll expand it. 3V minus 150 plus V plus 1.5V minus 30 minus 30 minus 30 equals 0. Now 3V plus V 4V 5.5V. So 5.5V equals 180. See, minus 150 minus 30, 180 we will get. So V equal to what? 180 upon 5.5. So when it will just divide and see 180 upon 5.5, you will get 32.727. 32.727 volt we are getting. So we got 32.727. That is the V. This V equal to 32.727. Now we'll find the current I2. I2 is flowing through 30 ohm. So I2 equals V by R. 32.727 upon 30. What is the value we get? Let me divide and see. Divided by 30. 1.090, which equals 1.090 amps. So all the three methods we got the same answer. So however you like to solve, whichever nodal analysis, mesh analysis or superposition, whatever you like, use it, you will get the same answer. So guys, thanks for watching. If there are some more problems I'll be providing in the network theorems so that you can learn and practice yourself. Thank you. Thanks for watching. Thank you.